because Tom is leaving one week earlier. So on May 28th, only Tom's group will give a presentation. Okay, the video, and we can ask them questions. Then we will still have class. Okay, and so the final exam will be on June 4th. Okay, the final exam will on June 4th. Keep that in mind. The final exam will on June 4th. Okay? And I haven't asked my grad student. Hopefully we can have final exam on the main campus, and we don't need to come here. But if we cannot find the room, I'm sorry, then you guys must come here again. Okay? So the final exam will be on June 4th. And some students ask about the type of equation. As I mentioned, the equation will be pretty much similar to, I will put like 60 or, for example, like this question, okay? For example, like this question, I adapt this question from the textbook, okay? So 60 to 70%, I will get 60 to 70% question from the textbook. But I will change the number, okay? I will change the number. For example, I will change this to 0.05. Change this to 0.003, something like that. Understand? I will change the number. For 60 to 70 questions, I will adapt it from the textbook. Okay? I don't give the previous exam, I don't give all exam. Because if I have a previous exam, Kaukuki, right? The student will be very lazy. Okay? And also, the question is very similar. Okay? And the rest of 30% and 40% from my handouts, from my notes, okay, from my lectures, what I mentioned in my lectures. Okay, so if you are very concentrated in my lecture, I think you can ask my exam. Okay? And the last day will be June 11th. Okay? So every group will give the presentation here. Okay, but we're gonna have lots of spare times. So I cannot buy you guys pizza. I'm sorry, Tom. You cannot have pizza. I can buy you pizza. I'm your friend. Okay, so maybe I can buy a small pizza for the group present on May 25th, 28th. Okay? So the last day will be the presentation at the party time. Okay? Okay, so if you do not have the textbook, go find one. Okay, go find one. No matter it's paper-based or electronic based. But the problem is you cannot bring in the electronic versions. Okay, because the iPad or cell phone is not allowed for exam. But keep in mind, you need to bring a calculator. Okay, you need to bring in the calculator for exam. Okay, so next I'm going to talk about the backhouse. The backhouse. Actually, the principle of backhouse is a giant vacuum. Okay, so it's the same principle as the home vacuum cleaner. Okay, so you can consider it's the giant 2-story tall. Okay, normally two or three story tall. Giant vacuum cleaner. Okay? So, the backhouse is the air pollution control device. Help us to remove we can use it to remove particulate matter, such as dust, fly ash, and some fine particles from the gas stream. Okay? So it works like a home vacuum cleaner. So the concept is, okay, I can use this. Just like this. Okay, normally 2 stories or even 3 stories now. Okay, the concept is the dirty air in. Okay, the dirty air in. And those particles, the dirty air is in, those particles trap. Those particles trap on back. This particle is going to be trapped on back. Just like a vacuum cleaner, right? So sometimes we also call it back filter. Okay, those particles will trap on back, then clean air out. Very simple, right? Just like a vacuum cleaner. Okay, so it based on the pressure drop. Okay, based on the pressure drop. And, oh, I'm sorry. I mean, it will cause pressure drop. It will cause pressure drop. Okay, the pressure drop will become too high. Okay, because the fan, for example, because the fan need energies. Oh, the gas flow. The reason, for example, like gas flow becomes weaker. Why the pressure drop generated? Because the gas flow becomes weaker. All the bag with so much dirt, right? The bag becomes less efficient. So we need to clean every 2 hours. So you should clean it every 2 hours. You should clean the back or replace the back. Okay, you should clean the back or replace the back every 2 hours. Okay, you can clean the back simply by mechanical wrappings. Okay, just shake it. Okay, or you might use the high pressure air jet. Okay, you might use the high pressure air jet to clean it. Okay, think about it. I said this is like vacuum cleaner, right? Most of vacuum cleaner can only clean the dry thing, right? The same things. The backhouse, the disadvantage of limitation of backhouse is this only used for dry gas stream. Okay, it's only used for dry. The backhouse should handle dry gas stream. So you need to be careful of the fire. Be careful of fire. Okay, And the bag, some of the bag is very expensive. So it's impossible that you replace very often. Okay? But the problem is the bag will ripens with time. Okay, so if your bag ripens, don't just clean it. Replace the new one. Okay? So now you need to replace a new one. Okay, and normally we will in conjunction. In conjunction means connect with. Okay, connect with the flue gas desulfurization applications. Okay, so this is used to remove SO2. Okay, this is used to remove SO2. Flue gas desulfurization means this flue gas desulfurization system is used to remove sulfur dioxide. Okay? Everyone okay? Okay, you know the reason we need to remove sulfur dioxide, right? Because sulfur dioxide will cause acid rain. The sulfur dioxide will cause acid rain and also corrosions. And even some health problems. For example, like some respiratory problem, or even some environmental damage. Okay, so we can use this so-called FSD, flue gas desulfurization system, to remove sulfur dioxide. Okay, that means we can put some reagent, for example, like sodium sulfate, sodium sulfurs. Okay, sodium sulfite and magnesium oxide. Okay, and also this reagent, you don't need to throw away. You don't need to simply throw away the reagent, because this reagent can be regenerated and reused again. Okay, so we have two systems for FGD. First one is wet scrubber. So the wet scrubber means the flue gas will contain liquid gas, liquid solutions, or slurry. Okay, so the wet scrubber means the flue gas contacts liquid solution, liquid phase solutions, or slurry. Okay, and the spray dryer means the reagent slurry is sprayed into the hot fluid gas. Okay, so reagents slurry is sprayed into hot fluid gas. Okay, reagent slurry is sprayed into hot fluid gas. So the sulfur dioxide reacts with reagent and the water evaporates. Okay, so this big house normally can in conjunction with those FGD system like wet scrappers or spray dryer. Understand? 这个 big house 啊，常常会跟这种处理 FGD 的结合在一起。All right. So this is the outside of the big house. Look like this, and inside you're gonna have the composition. You're gonna have this natural or synthetic fiber. Okay, so the lifetime for the bag is around 1 to 5 years. 1 to 5 years. But if you see it ripped, broken, right? Ripped, broken, you should change a new one, a new bag. Okay? And I found this table pretty good. This is not from our test group. Okay, I forgot where I found it. I found it somewhere, maybe from internet. Okay, so this is very good. For example, if you want, so take a look. If you want acid resistance, okay, if you want acid resistance, you should choose this. Okay. For example, like polypropylenes is excellent. Okay, but P84 just very good, just very good. Okay, but for alkaline means basic, means base. Okay, basic resistance. If you want to do basic resistance, then don't choose P84 and fiberglass because they are just fair. Fair means just okay, not very good. Understand? So this is pretty good tables. Okay, this is good for, because the big house is used a lot in industry. Okay, so this is really good tables. In the futures, okay, if your boss asks you to replace the bag, right? Then you can check. Then you can check on this table and give suggestion to your boss. For example, like if your boss wants to, okay, for example like this. This 2 is P, right? If your boss wants this to be fireproof, 防火, okay, flammable, okay, flame resistant, then don't suggest this 2. Understand? Because they are poor for fireproof. Okay? You might suggest this 5. Okay, so if you suggest, for example, if you don't know about this, then your boss want the bag to be what fireproof, right? Then you suggest this too. This too might got burned, right? Might got burned out, and you might get fired as well, and you'll be kaichu, right? You might your bag got fired and you got fired as well. Your bag got fired by really fired, but you got fired by your boss. Okay, I think this is pretty good. Okay, pretty good. Okay, pretty good tables. Okay, your list two is not fireproof, right? So you can see their operating temperature is lower. It's lower than others, right? Okay, next one. I'm going to talk about the cyclone. Okay, cyclone is also used to remove the particulate matter. But the bakehouse is good for the fine, the smaller, and even larger. But the cyclone is only good for larger, especially for the particle larger than 10 micrometers. Okay, so the principle is they use this spiral motion. Okay, like what the not dryer machine, the washing machine, right? This uses these spiral motions. And the diameter of the cyclone is very important. Okay, the rule of thumb is as the diameter reduce. Okay, as the diameter reduce, the efficiency increase. Okay, the diameter decrease, the efficiency increase. Okay, and also you might use the multiple tubes. You can call this multi-cyclone. Okay. So the dirty air comes in here, the clean air goes out here. But the problem is, this is also only good for the size greater than 10 micrometer. Okay, so the contaminated air comes in, the clean air goes up, and how about those particles? Okay, those particles. Okay, the underflow is, so the bottom outlet is for the underflow, where the collections of the particulate matter. Okay? Okay. I also want to add some notes here. Okay, I want to point out why I mentioned as the diameter reduce, the efficiency increase, right? So diameter decrease, efficiency increase, because smaller cyclone creates stronger springing motion. Okay, the reason as diameter decrease, the efficiency increase is the smaller cyclone, the stronger the springing motion. Understand? Everyone okay? Okay, so okay, so this slide tells us. Okay, so we also have some question for cyclone. So the radial velocities, okay, is very similar. This equation is very similar to Stokes' law. Okay, so the radial velocity is defined like this. Okay. So based on this formula, student, the small letter d, what is this? Small letter d is the particles, is the diameter of particles, right? It's diameter of particles. So as this increase, VR increase, right? Okay? The larger the particle size, the larger the faster. The larger the particle size, the faster the radial velocity of a cyclone. Okay, so therefore, what does it tell us? This tells us the larger the particle size, the faster the cyclone. This tells us the larger and heavier particles are easier to remove. Right? The larger and heavier particles are easier to remove. Okay, next. Okay, so this is radial velocity, right? How about tangential velocity? Okay, so the relationship between the radial velocity and tangential velocity is here. So the faster the radial velocity, the faster the tangential velocity, right? And you can see a square here. So the VR is proportional to V tangential square. Therefore, this so-called separation factor S, the S is defined as VR over VR over V. This V stands for terminal setting velocity. This V stands for the terminal setting velocity by gravity. So as you can see, the separation of cyclone is corresponding to what? G, corresponding to gravity. Okay, and S may range from 5. S may range from 5 to 2000, 2005, 2500. Okay, we also mentioned about a pressure drop, right? We also mentioned a pressure drop. Pressure drop, right? So the Q is the flow rate, right? Q is the flow rate. So delta P is proportional to flow rate squared. Okay, so if the flow rate increase, the pressure drop. If flow rate increase, pressure drop. If flow rate increase, pressure drop increase. Okay, so if the flow rate increase, pressure drop increase. That's why I mentioned here, right? Okay, so if the if the flow rate increase, pressure drop increase as well. The cut diameter DC. Cut diameter means the particle diameter at which 50% of particles are removed by cyclone. Okay? So the physical meaning means the smaller the DC, if DC decrease, the performance will increase. Okay, the DC decrease, the performance of cyclone increase. Why? Because this means this cyclone can remove smaller size. Okay, if DC decrease, then the performance, if the DC decrease, that means the performance of this cyclone increase. Okay, because that means this cyclone can be used to remove smaller particles. Finally, the number of turns. Okay, so it's defined like this. So if n increase, so if n increase, this means okay, if n increase, this means collections of particles improve, increase. Improvement of, maybe I say improvement of particle collection. Let me change this. I'm sorry. Improvement of particle collections increase. So if n increase, that means improvement of particle collection increase. Okay. Okay, this is from another test group, but the same thing. Okay, the same thing, but more in details. We talk about. They use D 0.5, but we use DC here. And the C dots, okay, C dot equals N here. C dot equals N. Okay, let's finish this question before we enter this class, okay? Well, we only have 1 minute. Okay. So this question we have, in this question we have D. The cyclone barrier diameter is 0.5. And gas flow is this. And this is gas temperature. And D is 10 micrometer. And density of particles is 800 kilogram per meter cubic. Okay, those given. Okay, so this is the dimension of cyclone. Okay, so you can use theta or use N. Okay, so let's find out N. You might use theta or N. Okay, this question uses theta. Okay, you can use N. You might use N or theta. Okay, so N equals pi over 0.25 times 2 times 1.0 plus 1.0. So N is 37. So N is 37.7. So this is effective tons. Effective tons. Okay? Then let's find out the D 0.5. Okay? So use the appendix we found the dynamic viscosity is this 18.5. Okay, then we plug in this formula. We can find out D 0.5. This amount. Okay, this amount. So D is 10 micrometer, right? Over 2.41. We got 4.15. We got 4.15. Okay, then we go back. We got this value, right? Then we go back to this table. 4.15. So this is 4.0. 4.15 is around here, right? So 4.15 is around here. So it goes up. So it's about 0.95. Okay, so this 0.95 tells us the collection efficiency is around 95% in this case. Okay, did I give you the solution for this question? Oh, okay, do I give you this? Okay, please take a photo. Wait a minute, let me erase this. Okay, this equals N. Okay, please take a photo. Okay, and we need to get this value, right? This is what we need. So after we get this value, we go back to this chart. Okay, we go back to this chart. Then we find out it's around 95%. Okay, so I might give this kind of questions in the final exam. Okay, I might give this kind of question in the final exam. Alright? All the questions will come from the lecture notes, the textbook, and my additional information I given. Okay, the additional information given in class. So I totally believe, okay, I truly believe, if you concentrate in class, okay, you can ask my exam, okay, from my experience. Alright? Okay, that's it. Did you guys take a photo of this? Everyone, please take a photo of this. Okay, so that's for today. Let me take attendance. 来点名一下吧。Before everyone leave, okay? 秉杰、庭月、孟轩、品纯、少奇，没有了。打仗还没有了，好，那作业也只交。嘉伟、邵鹏、Stone、陈亮、泰正、俊志、义祥、Rainer、Happy。